Hi, and welcome to Chapter 5. In Chapter 5, we're going to continue working through our modeling that we do and do some advanced concepts. So we're going to be taking those ER diagrams that we've been building and add a couple more components to them. Let's get started. There's about 6 new concepts that we're going to be adding to our entity relational diagram. And so we call them at this point an extended or enhanced entity relational diagram, or an EERD. So 2 E's in front of the relational diagram. Couple of things that we're going to be talking about. Supertypes and subtypes. We're going to be grouping some items and talking about how we can do that. We're going to be talking about a different hierarchy so that we can specialize our hierarchy to handle things like inheritance. We're going to be talking about constraints. We have a disjoint and overlapping constraints, so we're going to talk about those. The concept of completeness and specialization versus generalization. And these are concepts that we'll go through one by one with different slides to help you to understand exactly how they reference in your ER diagram and how they're used. So first off are supertypes and subtypes. This is kind of getting into the concept of inheritance, and assuming that you have taken an object-oriented language before, you should understand the concept of inheritance, where we are grouping into supertypes and subtypes. When we talk about data tables and things like that, sometimes you'll find that there are multiple things that you're putting into tables that are actually really grouped together, but they have some attributes that are different. Different types of employees might have different attributes associated with them, and you're kind of looking at it going, well, they're employees, so they kind of all need 80% of the same attributes, but then salaried versus hourly employees. Hourly needs to do a time card. They need to put in their hours, and it can change per month, whereas salary is usually a set amount that they get per month, whether they work overtime or anything like that. So if you were looking at that kind of a concept, you could separate out hourly employees versus salaried employees. But when you look at the table descriptions for both of those types, you'll notice, again, 80% of them are the same. They're going to have first name, last name. They're going to have a date of birth. They're going to have an employee number. They're going to have an address, city, state, zip. These are all things they're going to have in common. So the same way when we built object-oriented design classes and inheritance in our Java class or any other language that you've learned, we're going to do the same concept here and create supertypes and subtypes, or parent types and child types, same concept. The subtype will have all of the attributes of the supertype, but the different subtypes are going to have some things different. You want to make sure that your subtypes aren't just grouped together just for fun. There actually has to be different attributes in there that are at least unique to one or the other. So when we have a subtype, we have what we call a discriminator, or the attribute that exists in our supertype class to tell us what subtype we're going to do. You've seen this in a couple of the diagrams that you've already used, where we're talking about an employee type, or maybe with the pilots, the medical type. A couple of different types that we have in there, and you can have those types either be, say, a Boolean, is book, is movie, is CD, is music, or you could have it be an ID field that could be either an integer or a string. So like your employee type or your product type, different types of ways of describing your subtype to your supertypes class. The cool thing with breaking these into supertypes and subtypes is that you do avoid a lot of nulls. So if you could imagine, if I had an employee and salaried employees don't have an hourly rate, but hourly employees don't have an annual salary, I'd end up with all these extra random nulls in my data, where because of this type, I don't need to put any data in this field. But if it's this type, I do. And that's where it can get a little bit confusing. So being able to break it out like this is going to allow you to group together some of your fields in your tables and give them unique attributes that are associated only with that type, and avoid any data confusion by having random nulls in the middle of your data. Let's look and see what this looks like before we go much further. All right, so don't freak out. Yes, this is an ER diagram with a couple of new things that we've added to it. And you can look through, and I'll just kind of point out the different things, and then we're going to go through them and explain how you fill them out, what the notations mean, and so on and so forth. We have an employee, because we've been talking about employees, so I figured we'd go with employees. So we have an employee, and again, we have an employee number, employee name, first name, last name, hire date, type, so on and so forth. And they're related to their dependent, because remember we talked about that with insurance, how they have a child or a spouse, and that's their dependent. So existing relationships still exist. So if you're going to take a type and break it into subtypes and supertypes, those existing relationships still stick there. So the fact that we have a dependent that is associated with the employee ID, that still stays. So I just wanted to say you already know that one, the inherited relationship concept in your crow's foot. So now if we go down, we have a couple of things here. We have this little circle with a D in it with a line underneath it. Those three things, that's actually a couple of things that you're looking at all at once. One is you're looking at whether it's disjoint or overlapping. We'll explain that. The symbol, which is either a D or an O, which again relates to that disjoint or overlapping. The partial versus complete constraint, which is going to go into mandatory versus optional type thing here. And then what we call, again, the subtype discriminator. We like to write the name of the subtype discriminator on this line so that it's really obvious what field it is that was discriminating to tell us which subtype we're going to split this into. As you can see, we've listed the subtype of employee type, and that's going to be our discriminator. So employee type exists in our superclass that has all of these shared attributes, no matter which subtype we pick. They're all going to have all the fields from the employee table, including, of course, that employee type. That employee type is going to be a letter. It will either be a P, an M, or an A. P for pilot, M for mechanic, and A for accountant. These are all three types of people that you could have as employees. You could also have hospitality, flight attendants. You could have ticket counter. You could have maintenance crew or baggage crew or anything else in the middle there. So lots of different options that we have for subtypes of employees of this airline. We're going to go with an airline because there's a pilot. Then you can see how we've broken them out into subtypes. We have our pilots, our mechanics, and our accountants, and those are all subtyped. And they have different pieces of information related to them. A pilot would have a license, because he has to have a pilot's license. He would have his ratings that are associated with what his pilot's rating is, and medical type or med type. I'm not entirely sure what that one refers to because I don't do piloting. But those are three things that are associated with pilots. Mechanics don't have a license. They don't have the same thing. So that wouldn't make any sense to have employees who are mechanics follow those same fields. But if it's a pilot, we need those fields. So you can see how if I was going to create an employee table without subtyping this, I'd have a lot of fields in there that are null for everything except one type. My mechanic has his title and his certification, and my accountant has his title and his CPA date, which is different than obviously the mechanic's certification. So you can see how we've broken out into subtypes of our tables to allow us to kind of organize. I just want to keep my pilots here because I need certain pieces of information for them, but I want to keep my accountants over here because I need other information for my accountants. I don't need to put all of these fields into one table. I can split them out. Okay, let's go describe what all of these extra little pieces mean. We'll start with the disjoint versus overlapping. So this is that little circle with a D in it. It's either a D or an O. And the concept of disjoint versus overlapping simply says, can the entity be in more than one subtype? Are you allowed to be both a mechanic and an accountant at the same time? Are you allowed to be both a volunteer and a staff at the same time? Are you allowed to both be a movie and a book at the same time? If you can only be one option, you cannot be both. We call that disjoint. You can only be one type. And we put a little D in that circle, and that tells us when I have a person that is in my super type entity, in this case member, if you're a member of whatever organization we're working with, you have the option of being a volunteer, or you can be a staff. A staff gets paid, a volunteer doesn't. We have to keep them straight because they're going to have different pieces of information related to them. If you're a volunteer, I don't need to store what your hourly rate is because you don't have one. So it wouldn't make any sense. But you have to be either a volunteer or a staff. You cannot be both. So really important, we call that disjoint, being able to only be in one group or the other. The other option, of course, is overlapping. Yes, you can have a story be either a book or a movie or both. Lots of movies have been made, or lots of books have been made into movies. Some movies have even been made into books. So you can be both a book and a movie at the same time. You don't have to. You can be just one, or you could be both. So in that case, we give it the overlapping constraint, meaning that you can have more than one at the time. As you'll notice, the constraint that we're using for our story is a Boolean value. Is it a movie? Is it a book? This way we're able to figure out, okay, I can have is movie and is book both be true, in which case both subtypes will work. Or I could have is movies true and is book is false, and that would mean it was just a movie, and vice versa. In the member over on the left-hand side, it is related to member type. That's a single value. So you can only have, is it a volunteer or a staff, as your member type options. We can have that as a single field rather than having it as a Boolean field, because your option is either you're one or the other, but you can't be both. We don't have to worry about storing two things in there. Whereas if you do have an overlapping constraint, you're going to want to use something like a Boolean. Are you a movie? Are you a book? Type thing, just to keep it straight. By the way, you can have multiple subtypes. So you can have 2 or 3 or 4 options here, and you can have overlapping into all 4. So in this case, you can understand how a Boolean would work a lot better to determine, is it this subtype? Is it this subtype? Is it the third subtype? The next constraint we're going to talk about is completeness. Now, the completeness refers to, is the subtype required? Sometimes you're going to have an employee and then you have a subtype of pilot. Well, not all the employees are pilots, so you can have an employee who is not a pilot, who doesn't have a subtype, and that's okay. That's called a partial subtype. You don't have it required. You're allowed to have null as that discriminator. That's allowed because it is a partial constraint for completeness. The other is total completeness, which is where you have to be one of the subtypes. If we're going to have our story, it is either a book or a movie. It cannot be neither. It has to be at least one or the other. So when you are required to have your subtype, it is called total completion or total completeness. And in that case, we use 2 lines as opposed to a single line underneath our circle that holds our disjoint overlapping option. Did I lose you yet? Hope I haven't lost you. Let's try to keep going. The next part of this is, how did you build your types? There are 2 different ways that you can look at it. You can do it specialization, which is top down, or generalization, which is bottom up. Top down means we start with our super type, employee. How can I break my super type in? I can break it into either a crew or a maintenance for my plane. Okay, my crew can include pilots, co-pilots, maybe flight attendants, hospitality. Those can be in my crew. Whereas maintenance is going to be my ground crew or my baggage or things that are like that are more related to maintenance as opposed to the crew of an individual plane. You can see how a pilot would have different things to store in his employee than the baggage guy that handles the baggage. Those are going to have different pieces of information in them, and so we can separate those into the 4 different subtypes off of employee to tell us what type. That would be top down, starting from employee going down. The other option is generalization, where we are going to generalize our employee types as we move up. So we start with all of the possible subtypes we can come up with. Give me every single description of a job that somebody does. So all of the different types of jobs that you can have: admin assistant 1, admin assistant 2, faculty, adjunct faculty, volunteer, whatever all those are. And then generalize them into groups. So we could go to the pilot hospitality and move that up to crew. We could take the ground crew and the baggage and call those under maintenance. Then we finally get to the super type after we've generalized crew and maintenance all the way up to employee. It depends on your situation which one of these 2 is better. There is no perfect answer. because you can obviously get both directions either way if you want to specialize from the top down or generalize from the bottom up. Either way works. And that's different ways to just build your types. You're going to feel which way works better for you based on the knowledge that you've been given. So if your client gives you all of the different job descriptions that he has, you might want to go with generalization, because you can start breaking those into, these are admin jobs, these are management jobs, these are floor jobs, whatever it is, different types of jobs. Okay? So let's go back and look at this again. Same chart that I gave you 10 minutes ago. Again, we have our super type of our employee. We have our circle with our line underneath it, which means that it is a disjoint, not overlapping, which means you can only pick one of the three jobs. The partial complete is partial, which means you do not have to have one of these three jobs. You can be an employee and not be a mechanic or a pilot or an accountant. You don't have to pick one of the three. You can be something else. Owner, that would be fine. So because it's one line underneath our circle, that's going to tell us that it is partial, not complete. Then, of course, we have our subtypes and the different fields that go along with that, with our subtype discriminator listed out on the side. Hopefully that helps you to see this a little bit better and see the different things about it. Remember that employee type, it's either going to be A, P, or M. Those are the different choices that we have for our employee type, our subtype discriminator. All right, now that we've got that covered, let's break into another way of doing our entity relationship, and that is called entity clustering. When you start on a new project, you might have 5 or 6 or 8 tables, and you can get them all in one page and it looks beautiful and you're fine. The more you build on your database, the more tables you create, the more information you're trying to fit on one screen, and the harder it is going to be to keep it all straight. So what we do is we tend to break up your ERD into clusters to make it easier to read. We can then print out the whole ERD, which could be a collection of, say, 20 clusters or 10 clusters, and then print out each of the clusters separately to make it so that you can see the visualization of all of the ERD broken up into sections. It's kind of like looking at a book and you can see there are 10 chapters, and then each chapter has 10 things inside of it. So we can look at that. These are virtual entity types. You're not going to create an entity that's going to do this. This is nothing you're building in the database. This is literally just for visualization purposes to make it so that you can see what's going on better. What we're going to do is group multiple tables into a single cluster. In the example that we have here, our 2 blue tables are clusters. They're entity clusters. So offering would be the collection of what semester, what course, and what class. So remember, we had that class where it was CSCI 240, and then this one was spring semester, and this was online as our location, something like that. So that was the information that was going to go into the offering. You also attached to the offering the location, which could be a room and a building. Remember, if you've got multiple buildings, if you're in a larger college that has, say, 15 buildings on campus, you need to know which building and you need to know which room in which building. We don't need to have the 5 extra tables on this page, because the purpose of this page is to be able to visualize the school, department, student, and enrollment, and then be able to simplify that offering and location a little bit better. Our purpose here was to see professors and departments and how those interacted. So having all of the different tables, the extra 5 tables that would be there for the offering and the location, aren't necessary. We can cluster those, group them together, and then create a cluster ERD of just the offering. And we can create a cluster ERD of just the location. All we need with the location is the offering and then the room and the building. With the offering, we could have the enrollment. We could even have the department and the professor. And the location, those 4 could go in, and then we put in those other 3. So we can cluster those ERDs to make them into a couple of tables as opposed to having too many. I actually have done a ERD for a company that had over 200 tables in it. Being able to ERD 200 tables onto a single sheet was very, very difficult. So we didn't, because it made so much more sense to cluster it break it down into this section. This was invoices, this was employees, this was clients, this was customers. And then each one of those had their own cluster ERD description for each cluster. All right, so I've thrown out to you a couple of times the concept of a primary key. Primary keys are so terribly important that we're just going to keep hitting you over the head with this. We introduced it probably in chapter 1 and 2 and 3. Let's do it again in chapter 5. Primary keys, again, most important thing to have because they help you to enforce your integrity. It's all about keeping your integrity. Remember, your primary key purpose is not to describe your row. It's not to give information about the row. The primary key is simply to enforce that integrity. That's its only purpose. So when you're looking at your tables and you're going, what is my primary key going to be? Couple of options. You can pick the natural keys, which are ones that are obvious. If I have an invoice table, my invoice number would be an obvious primary key because it should be unique to each invoice. So that's an option. With an employee, you could pick social security number. I don't, and we'll explain that in a second, but you could, because everybody should have their own social security number. Any type of identifier, driver's license, things like that you could also include depending on what you were talking about. If it was a car, it could be based on its license plate or its VIN number. Identifiers, these are natural, they're obvious. So your natural keys are the obvious keys. You didn't have to go find something, you didn't have to make it up. It was just there. It was already there as part of your data set, of part of your data field. Sometimes you're going to come up with composite keys. So your composite keys are going to sometimes be that linking table between two M-to-N relationships where it's obvious it's going to be the primary key from both tables that it's linking. That's going to be your naturally obvious primary key will be that composite key, and it's important to recognize that one. When you have weak entities in a strong relationship with their parent, usually the parent ID is going to be part of a composite key that's going to describe that weak entity. So you're going to have something about the parent's ID and then maybe another piece of information, maybe the date or maybe an ID number somewhere else in there. My favorite is what we call a surrogate key. It's the one that the database creates for you automatically. It is a unique identifier, or what I call a GUID. This unique identifier is created every time you add a record to the table automatically. It's usually a 16-digit hexadecimal number. You cannot guess it. It is pretty safe, and it doesn't actually mean anything other than I am the ID field for this row. There are 6 different things that you want to think about when you're creating or selecting your primary key. The first is that it has to be unique. Has to be unique because otherwise it doesn't make any sense. You have to have a unique primary key. The second may seem a little bit interesting. It should be non-intelligent. It shouldn't actually tell you anything about the row. We don't want to describe the row. The purpose of a primary key is not to describe it. So putting in things like your social security number actually does tell you something about the row. Putting in a primary key of first and last name does tell you something about the row. So picking your primary key is something that generally we think of as non-intelligent. It should be just an identifier that does not actually tell us anything about the data. Third, it cannot change. It never should change its value. So you wouldn't ever want to pick something like an age or even a name. If you picked a last name, what if the person gets married? What if they change their last name? What if they are married and they get divorced and now they change their name again? You don't want to pick anything that could possibly change over time. So you don't want to think about it as like their address, a name or something like that. Even license plate numbers change over time depending on if they change owners. So you may not even want to use like a license plate. VIN numbers shouldn't change, but license plate numbers could. So you want something that doesn't change over time. We prefer to always try to use a single attribute, a single value. If you can avoid a composite, please avoid a composite. If you can't avoid it because it's a linking table and you have to use a composite, go ahead. I mean, it's doable and we do it all the time. We just try to avoid it. And there are sometimes I'll actually make a surrogate key for a linking table that has the 2 primary keys in it, just to create that single attribute as opposed to having it be composite. It allows searching much better and it allows indexing better. We also prefer numeric. We prefer numbers. Hexadecimals are numbers, so they work. But we don't like strings. Numbers are easier to sort and they're easier to look up. So strings take a little bit more effort. You have to convert them from the string back to a number and change it around like that. Whereas numbers are just easier to calculate for indexing and for looking up. So being able to do our joins on our keys automatically, that comparison is an easier comparison than doing two string comparisons. So we like to make our primary keys numeric. And the last piece of information is it has to be secure. Imagine if I put my credit card number as my ID field, and then somehow in a website that was doing it, I used my ID field up in the URL to get to my records. Well, now my credit card number is open for everyone to see. You cannot give away secure information. So you want to make sure whatever you pick for your primary key, it is not something secure. It is not something like a social security number or driver's license number, date of birth, anything like that. Even first and last names you really don't want to use because that's someone's name. That might be covered under confidentiality and you may not want to have that as your key. That would be saved and then possibly used throughout to try to find those records. So these are just a couple more things to think about when you're making your primary keys. All right. When we get towards the end of this chapter, you're going to find that there are 4 design cases. And I'm including them in here because I do think they're important parts about this lesson that you need to learn. The first one is how do we handle one-on-one relationships, one-to-one. Remember, the only reason why you would ever have a one-to-one is because for every value that exists in one table, there is another value in another table that are directly related to each other. You could have a one-on-one relationship between, say, an employee and then date of births. So you could have date of births over in your one-to-one. Although in all honesty, you could have 2 people with the same date of birth. You want to really avoid your one-to-one relationships as much as possible. But if you have to do it, that's okay. Let's see if we can get it right. When we first introduced one-to-one, we said the way to enforce referential integrity between them is you add a foreign key to both tables. So you add a foreign key. So if you have table A and table B, you add table A's primary key into table B, and you add table B's primary key into table A. We don't actually do that most of the time, if you can avoid it. It's such a bear. Especially if it's mandatory, because then you get into this problem of when I'm adding it, the second one doesn't exist yet, and then it becomes a problem. So we're going to start with the option of one of them is mandatory and one of them is optional. So this would be where you have 5 pieces of information about an employee in your regular table, table A, and then in table B, you have some alternate information that you may or may not have. So it's optional as opposed to mandatory. The way we fix this is we take the primary key from the one table and we add it as the foreign key in the secondary table. And we make that foreign key a mandatory field. So we have to add it in this case, and it'll be added into table B in the situation where table A is mandatory and table B is optional. So you can do this, and this is the way that 90% of your one-to-one relationships are going to go. You're going to end up adding a singular foreign key to your secondary table, and you're going to make it mandatory and you're going to move on from there. Sometimes you have it where both sides are optional. You could have some information in A and some information in B, and sometimes you don't have it, sometimes you don't have it on the other one. They're both optional and it throws everything off. What you do is you need to look at both tables and figure out which direction seems to make the most sense that will create a situation with the least number of null values. Remember, you're going to be adding a foreign key into one of your tables, which is going to be the primary key from the secondary table. So of those 2 tables, which one has the most values that are not filled in, that would give you the least amount of nulls? That's where the direction we want to go in, because we want to avoid null values as much as possible. The last one is where both A and B are both mandatory. If both A and B are both mandatory, why is it 2 tables? Because if they're both mandatory, they should really kind of be combined. And in most cases, when you're first designing, you're like, well, yeah, totally, this is 2 different pieces of information, but it's mandatory that you have both sets of information. So if I had an employee and I had the mailing address for the employee, do I need to have a second table that only allows one mandatory mailing address? Why don't I just add the mailing address back to my employee table and leave it there? Because there's no other place that that information is. It's a one-to-one. It's not like it's all my possible addresses. It's just the one mailing address, and there's only one option for that. So maybe it really should be in with my employee table instead of breaking them out. But if after fighting yourself, you decide you still want to have a one-to-one mandatory relationship, look at it again like we did on that second option and figure out which one produces the least number of nulls. You want to include the foreign key in such a way that you have the least number of null values. And that's okay because it's one-to-one. You're going to probably find what seems logical. If I had employee and I had addresses, I'm probably going to have a address ID as a foreign key in my employee table, and that's going to link to it there. Because it wouldn't really make any sense to take my addresses and put the employee ID over there, but you could because it's one-to-one and it doesn't really make any difference. So when you end up with a one-to-one relationship, think really hard. Do I need this one-to-one relationship? Is it optional or mandatory? And how can I handle this with the least number of nulls? The second design case. This one happens all the time. I am not kidding. I hope if you remember nothing from this class, you remember that I told you you're going to have to deal with maintaining history. Fun thing with maintaining history is most of the time when you start a new project, you're not thinking about history. You're building your database, you're building your tables, everything's fine up until you start implementing it and you realize you didn't handle history. In the real world, someone will always ask you, what was the job the guy had before the current job? What was the old salary? What date did he get up? What time was he hired for the first job that he was hired for before he got upgraded to the second job? And you stop and you go, I don't know. I actually changed the records in the database, so I don't know what it used to be before I changed it. Uh-oh, we have to handle history. Being able to keep track of changes in anything, job status, pay rate, job title, address, city, state, zip, phone number, you need to keep track of history. These are called time variant. They change based on time. So as time moves on, they vary. Time variant data happens all the time. So you'll feel it when you're building your database. This piece of information is time variant. The way we solve it, and actually there are lots of ways to solve it. One of the ways, the way the book explains it here, to solve it is that you create historical data tables. You change your attributes to create a table to store just the time variant data. So in this situation, I had an employee, and the employee had a job code and he had a salary. And then I realized I wasn't storing a history of that job code and that salary. I was just putting them in the employee table. So when the guy got a raise, we just changed it automatically. We changed his salary from X to Y, and we changed his job code from something to something else. Well, that's okay, except that there comes a time that management comes back and says, we need to know what his salary used to be. I don't know, I changed it in the database, it's gone. Then they get cranky. So we like to avoid making your clients cranky. So you want to do that by storing things like changing the job code and having some semblance of a date to handle it. So in this case, we have our employee number, our department ID, and then our date that was changed, the date that this thing started. So we can have you started on October 1st, and then January 1st, you got a pay raise. And then the next January 1st of the next year, you got another pay raise. So we stored all of this piece of information, and we can then pull back out the history. When you write your queries, you're going to do some semblance of constraints that are going to say, I only want to get the last one. I want to get the maximum date, which is totally doable, and we can do that. So you want to handle that by having that history in its own table. And I promise you, this really does happen. All right, the third design case that they refer to is what we call fan traps. The book claims that they're the most common. I actually kind of think that the history one is more common, but that's okay. Fan traps are what happens when you have an M-to-N relationship in some way and you're trying to find that linking table in the middle. Or you essentially have three tables and they're all kind of related and you're not entirely sure where to put which, and which one goes in the middle and which one goes on the side. So if you can see in the incorrect version over on the left, we have our team, our division, and then our player. Well, our players are all in the same division, but then they are in multiple teams. The question is, how do I figure out which team each person's in if this is the direction that I'm going? So I can link from my team to my division. So I know that they're in U18 as their division, but I don't know which team who's on because I'm just saying that there's two possible values for teams. I just don't know which one's which. And you've created this situation where if you look at your state machine, you look at the possible values and how they play out, you will find this fanning thing where it goes off on both directions and you can't figure out which one's which. You should never have that happen. When you write your database, you always want to be able to get the information out that you need. And if we did our database this way, with our many to one, with our team to division, and our one to many from the division to the player, we're not going to be able to go from the player directly to the team because we won't know it. The way to fix that in this situation is to flip. So we flipped our team and our division. So we said our division was U18, and then from our division, we went from our division to our two teams. And then we had our players going to that team. You can get to the division by going through the team. So you can get all of the pieces of information that you need for each of your players. So we call this a fan trap because it's really easy to make this mistake. What you want to do is look at every piece of information that you need and make sure you can always derive information from the third table or from each different table. So can I go from my division to find all of my teams? Can I go from the team to figure out all my players? Can I go from my players to find my division? As long as you can do that, you're okay, but you got to keep track of those. And our last design case, this one also pops up a lot. This is redundant relationships. When you have information in a database, we've talked about it a lot, you do not want to store duplicate data. As much as possible, you never want to store duplicate data. But sometimes when people are first starting their database, they can say, okay, cool, I have a player and I need to know who their team is and I need to know who their division is. Okay, I need to know that information for my player. So I'm going to store it in my player table. And then I'm going to have the team code that goes and tells me what the team is. And I need to know what division the team is. So I'm also going to store the division ID in my team. Well, I now have two tables that both reference the division, but they don't have to. I can go through my team to get to my division to derive the division ID from the team, and I don't need to store it directly. What happens in the real world in this situation is that you will have the division ID in two different places and someone will update one but forget to update the other, and then you'll have conflicting information, and then everything falls apart. So it's very important when you look at your data, if you have a relationship where you can get from one piece of information to another in two different ways, you now have a redundant relationship. In this case, the player can get to his division ID directly because he knows what he is, and he can get it through his team. You want to avoid redundant relationships because it's duplicate data. It's second ways of getting into something. And if you can derive it, you should derive it. You shouldn't be storing it unless there is a reason to store it. Okay, so hopefully that wasn't too much for chapter 5. This is the summary of all the stuff that we did. Remember, we updated our ERD by making it enhanced or extended, so our EERD. We added our subtypes and supertypes to make our clusters. We did disjoint versus overlapping to allow you to be multiple types. We did our partial and total completeness. Could you be a supertype without being a subtype? That would be partial. If you can't, it's total. We talked about how to build our types using either the top down or the bottom up, specialization and generalization. Talked about some cool things about primary keys to make sure that we covered our how to build our primary keys so that you keep those things in mind. And then we talked about our 4 different design cases with our one-to-one relationships, our time variance, our fan trap, and our redundant relationships. Okay, let's talk about your homework. There are a couple review questions. I kind of broke them out by what type of review question they were to try to kind of give you that heads up about what you're going to be doing. 4 through 7 are pretty much terminology. What does this word mean? What does that word mean? So those should be pretty easy. 8 through 10 uses the product data model to play around a little bit with that EERD. Okay. 12 and 14 reference those primary keys, and then 15 through 17 are what would you do in this case that are similar to our design cases. So these are the review questions that you're going to be doing, and then we have our problems. All right, so I only gave you 5. That does not mean it's going to be easy. Please, again, start early. Number 3, you're going to be creating an EERD for Granite Sales Company. So they give you a bunch of details about Granite Sales Company, and they're going to have you build your EERD. 4 through 6 all relate to the tiny college, but it's really clustering that I'm working on here. So 4 is your full ERD, and then 5 and 6, they add things. One is for job history and one is for staffing. I just want you to do the ERD for that segment. You can break it out into the segment. Do not include every table in tiny college. Just do the ones that are appropriate for the segment that you're working on. So if we're doing job history, you don't need to include tables that are not related directly to the job history stuff that you're going to be working on. Same with the IT staffing. Number 8 is the case. So I'm going to have you guys do the full crow's foot EERD. I'm purposely not adding this to SQL Server. You cannot go into SQL Server and run some queries against that. That's intentional. I want you to think about what the user is given, what pieces of information are included, and how you would build your own tables, entities, attributes, etc. You're going to come up with it all on your own, which means your answer probably won't look like mine, and that's okay. I want you to look at the data that they've given you and be able to break down, okay, these are the entities I need, these are the relationships between them, and this is how I would build my EERD, knowing all of the stuff that you know at this point. Make sure you label your primary key, your foreign keys, your relationship types. You're going to do a full crow's foot, so you're going to be including all of those things. If you decide to do subtypes, I'm not telling you right now if you should, but think about that as an option. Make sure you include all of the EERD stuff that goes along with those. So your discriminator, your partial versus complete, your disjoint versus overlapping, and then of course those subtype descriptions as well. Okay? This is going to be fun. So there's not a whole lot of work, but it's a lot of work to think about. Go ahead and give me a call if you need anything, and have a fabulous week.